Now, angles are a big topic, and in fact, there's many different ways to measure them or express your angle measure. It all essentially starts with the circle, where if we take a complete circle of 360 degrees and we were to fraction it up or separate it into different parts, we could actually, from the point of origin, measure the different angles that comprise each fraction. Now, in physics, we heavily rely on what we call rotation angles, and that is an object whose position is rotated along a fixed point. So imagine you got a fixed point in space, and then you're taking that object along that fixed point and moving it back and forth and perhaps underneath, but it's all centered around that vertex or fixed point. Now, there are three components to a measured angle. You have the initial arm, which is on the x-axis where the angle starts with, although it could sometimes be the y-axis, but that'll be later on. We have the actual theta measurement, which is the angle that's measured from the vertex point to the final component, which is the terminal arm, or the line where the initial arm has been rotated to. When we read an angle counterclockwise to the x-axis of 0, then that would be a positive angle measure. When we read the angle clockwise from the x origin of 0, then it is a negative angle. So like we said previously, you got to think about angles as a full rotation circle. So if this is the x-axis and this is the y-axis, our initial angle would be at 0. And then as we rotate, and so this would be like the initial arm, you could say. Let me just write that properly here. And so imagine that we take that and we rotate it all the way to here. This would be 90 degrees. Put that at the top. And then if we keep going all the way to here, this is now 180 degrees. We keep going all the way here, and then this would be about 270 degrees. And what I want you to understand is we're actually adding 90 each time. So the quadrants are separated really by 90 degrees each time. And then, of course, from 270 all the way back here, I'm going to write this in red. One full rotation is 360 degrees. The vertex, of course, that we're speaking about in this case would be the axis of origin at 0 and 0. So let's get to plotting the degrees. Let's say here we're asked to plot 290 degrees. Well, from the point of axis, we would go counterclockwise. Since it's positive, we'd go past 270, and then about here is where we would draw our terminal arm. And I'll draw it here like this, and I'll highlight it. And so the entire degrees, 290 degrees, is this entire purple kind of, not circle or semicircle, but kind of loop from, again, the 0 axis point. Now let's move to negative 90. Now that negative, again, it tells us that we're going to read the graph the angle going counterclockwise, or sorry, I should say clockwise. And so from the, again, axis of origin, we're going to move from here, and I'm going to do this one in red so you can see it properly, and we're going to go all the way here to 90, because remember, one full quadrant rotation is 90 degrees. And so what we would do is, in this case, and I'm going to undo the loop, since the line or the point would end up here, we would just have a red straight line. And what you kind of have, and I'll highlight this so that it's more apparent, you have kind of like an upside down or inverse 90 degree angle. And this is negative 90 degrees. So we went this way as opposed to this way. And then finally, the angle is 60 degrees. Well, that is a rather straightforward angle. It's going to stay within the first quadrant, or quadrant 1 over here. And we would simply plot the point. It would be roughly around here. Of course, you'd have a protractor that would guide you a little bit better and make it more accurate. But my angle would be something like this. And the terminal arm, and I'm going to draw it here. This is the terminal arm. I'm going to write T arm. And then your actual 60-degree angle, again, because it's positive, we moved counterclockwise. This area over here would represent the 60-degree angle. Now finally, let's say we have an angle that is greater than 360. Well, what we know is that, and I'm going to draw this here, past 360 is a full rotation. So when I go 360, I've stopped over here. However, my angle wants me to go more than 360. And in fact, if I go 450 minus 360, I end up with an additional 90 degrees. So it tells me that I should continue to go this way until I've reached another 90 degrees. And so how we would actually draw this, and I'm going to highlight this, is my terminal arm would actually be once again on the 90, except this squiggly line here kind of certifies or indicates that it's gone more than once. And so this over here is at the 90 framework, it's at 450 degrees.